Hey everyone. So I had a question from section 8.3 and it was question number 4. So I am in teacher mode here. So, the screen might look a little bit different, but obviously your questions will be similar to what I'm showing you here. So again, this is from section 8.3 and the question is number 4. So I did already solve it and I'll walk you through on how you need to go about solving this question. So let's take a look here. So again, this is question number 4 from section 8.3. So you can see the prompt for the question is you recently sent out a survey to determine if the percentage of adults who use social media has changed from 64%, which was the percentage of adults who use social media 5 years ago, right? So this is the data from the past. And they want to know if this percentage has changed. So the new information is of the 2,275 people who responded to the survey, 1,681 of them stated that they currently use social media, right? So this is the newest information. So our first question is use the data from this survey to construct a 94% confidence interval estimate of the proportion of adults who use social media. And then just some instructions. You do not need to round in between steps. And this is very crucial because if you start rounding in between your calculations, your final answers are going to be incorrect because you've done so much rounding beforehand that your final answers may actually be off by, decimal points or even by whole numbers, just kind of depends on the problem. And then your other instruction is give your answers as decimals to 2 places. Now you will see that in my answers, I actually did not do the rounding and it still accepted my answers, but in some questions, it is pretty persnickety where it may not accept if you do not round them. But as you can see for, again, question number 4 here in section 8.3, it accepted. All right, so let's go with the information that is given to us. We know 5 years ago, the population proportion was 64%. We want to know if that has changed. So they did a survey of 2,275 people. 1,681 of them said, yes, they are using social media. And then we have to construct a 94% confidence interval. So I actually did my calculations on a spreadsheet and I'm just using Google Sheets here. If you are comfortable using Excel, you should be able to do this in Excel as well. So you will see right here at the top, I went ahead and put the known information we have. So again, remember 5 years ago, our population proportion was 64%. Then the total number of people who took the survey, and how many of them said they use social media. So I have all of that information here. So now you can see, again, coming back to our problem, the first question they're asking us to find the critical value. Now remember, critical value in this case is we are talking about z-score over here. So I will actually go down to your textbook over here and I will tell you where I'm getting my formulas and stuff like that from. So if you actually go to section 8.1, so we're working in 8.3, but obviously everything is building up on itself. So how do you find your critical value or your z-score? So if you actually come down here, you will see that it shows you how to find your z-score over here in this little paragraph for a given confidence level. So we know our confidence level is at 94%, and based on that, we need to calculate our critical value. So I will kind of start that over here. So you can see we are at a 94% confidence level. And again, it is given to you here right in the question itself. So 94% confidence interval is what we need to calculate. So if 94% is the confidence level, we need to calculate our alpha. So you can see that's basically going to be 100 minus 94, or if you're doing this in decimals, you'll do 1 minus 0.94 and you'll get 6% or 0.06. So yeah, if you wanted to do this in decimals, then, like I said, that would be 0.94. This would be 0.06. And then you will take alpha divided by 2, right? So you've got your 0.06 divided by 2, which gives you 0.03, or in percentage, of course, that would be 3%. But remember, you do actually work with decimals here, so you want to leave this number as a decimal. Now, once you calculate your alpha divided by 2 value, remember, we're basically trying to figure out what the z-score is. So we are actually interested, and you can kind of see the description here in your textbook. If you know the area to the right, that would be the value we came up with, right? That alpha divided by 2. But if you want to know what the area to the left is going to be, then you would have to do 1 minus, alpha divided by 2. So that's exactly what we are doing here. We took 1 minus alpha divided by 2. So you can see that's where we are getting the answer of 0.97. Now we are going to need this value of 0.97 to calculate our z-score. Now you can see the function that it's giving you here. Now, of course, this is based on a TI 83, 84, and the pluses model for those calculators, but you can actually easily find a similar function for that in Google Sheets or Microsoft Excel. So if I actually click on this cell here, you will see the built-in function that we're using is norm inverse, or norm INV, which is not too different from the one they were giving you in your textbook here. So you will see I'm using cell references. So instead of typing the numbers, I'm just using, the calculations in the cells that we already did. So you will see I've got my 0.097, which is going to be our X value in this case. And you can kind of see the descriptions for that. Because we're kind of working backwards here, right? We don't know the z-score. So we know what the area is going to be to the left of that z-score. We just don't know what the z-score value will be. So that's why we're using the 0.97. And then since we're using a standard normal distribution as our basis of our calculation here, your mean will be at 0 and standard deviation will be at 1. And of course, again, guys, you can find all of that information here in section 8.1, which I'm guessing since you're at 8.3, you should be comfortable knowing that. And, of course, if you need to go back and reference, chapter 6 is where we first started talking about normal distributions. You can go back and reference that if you needed to. Anyway, so you can see what this function does and helps us come up with the z-score. So that's how you're going to type this in. Again, remember, this here is that 1 minus alpha divided by 2 value, which is the 0.97. Your mean for a standard normal curve or normal distribution is 0, and your standard deviation is 1. So that's where those values are coming from. I also wanted to show you just how I've typed in all these cells. So of course, all of these numbers are straight away typed in as they are. I'll show you these two here in a minute, but let's go back to the confidence interval. So 94%, you can see instead of typing 6%, I just did 1 minus and then whatever I typed in this box. So it's 1 minus obviously 94%. And then when I went down to my alpha divided by 2, you will see I again clicked on the cell where I had my 6% and I did divided by 2, which gave me the B8 cell reference divided by 2, which is where my 0.03 is coming from. Then when I had to do my 1 minus alpha divided by 2, I again did cell reference. It's 1 minus the cell where my 0.03 is, and I got my 0.97. Then, like I told you previously, I'm in my norm inverse or the inverse norm function. Again, I did a cell reference, typed in my mean and standard deviation, and got my answer. And the main reason I do that is, let's say if I wanted to use the same calculation for a different problem, like let's say I'm doing practice, or I have another problem which is kind of similar to this, and it has a different confidence in level, I can actually just come in here and change this to, let's say we're doing a 99% confidence interval. So again, I was at 94%. I'm changing it to 99%, and you will see all 4 of these cells underneath that will automatically change the calculation. So I don't have to keep going back and, rewriting all my numbers. So let's say I change that to 99%, and look, 100 minus 99 is 1%. Half of 1% is half a percent. So, as a decimal, that's 0.005. Then when I do 1 minus 0.005, I get 0.995. And then using 0.995 as my area to the left of the z-score, I can then come up with my critical value, right? So you can see I didn't have to change anything except that confidence interval box, and it makes my calculations easier. So that's kind of why I use the cell references. Anyway, let's get back to our problem. So you can see now I have my critical value of 1.8807. Now, if you wanted to round this to 2 decimal places, again, you can use Excel or Google Sheets to do that. So I'm just going to retype this in a new box. And then you will see here at the top, we can actually decrease or increase the number of decimal places. So if I keep hitting that decrease button, you can go ahead and round it to 2 decimal places. And then you could have also typed 1.88 in here, because remember, they are telling us to round this to 2 decimal places. So you could have typed 1.88 in here and you would have been fine. But like I said, I just did a copy paste from this cell and it accepted it. But if it doesn't accept in the problem you are doing, yeah, just come back here and, cut it down to 2 decimal places and you will be good to go. Alrighty, so I'm just going to delete that. So we have our critical value. We did good on this first question. Now the next one is asking us to find the margin of error. So your textbook actually calls it EBP. And for this, we will go back to section 8.3, which is what we're working in right now. And if you scroll down to this little section here, you will see it's called the error bound for a proportion, and that's where the EBP is coming from. So you've got your z-score value that we just calculated, and remember that's the critical value we just calculated here. And then you're multiplying it with the square root of p prime q prime divided by n. So your p prime is actually the value of your x divided by n. Now remember, the x divided by n is, and again, you can kind of see they have a little bit of description here. Sometimes we call it point estimate. Sometimes we call it, they're calling it the random variable p prime in here. Some textbooks also denote it as p hat. So you can see it's got like that little caret symbol on top of the p. So you would read it as p hat. So you've got different names for it, but basically this is where you are taking your 1681, which is the number of people who are using social media out of the total number of people who were surveyed, which is 2275. So if I go here, you will see I put the symbols of p hat or p prime. And if you go here, you will see this is where I took the value of 1681 and divided it by 2275. And again, I used cell references because again, if I went to a new example and the 1681, 2275 changed to a new number, then again, I don't have to go and do the calculations. Again, I can just change these two cells and my p prime will be calculated automatically, right? So this is where I got my p prime value from. So you can see that came out to be 0.738901, so on and so forth. Then over here under the EBP, they're also telling you what Q prime is, which is basically 1 minus the P prime value. So it's, again, you take it 1 minus or 100 minus, 73.8%, or you can think of it as decimals, 1 minus 0.738901, so on, right? So again, you'll see I use the cell reference for my Q prime, and I typed in, equal to 1 minus this cell, which will automatically, again, calculate the Q prime for us. So you can see we have our P prime value here, we have our Q prime value here, and then we can calculate the margin of error or the error bound for a proportion as your textbook calls it. So you will see again, you're taking the z value of alpha divided by 2. So you will see I am using this 1.8807, right, which is our z-score. So that's this number here. Then in your formula, you are seeing we're multiplying this because of the 2 parentheses, this is multiplication. And then we are taking square root of p prime multiplied by Q prime, and that divided by N. So you can again see square root. So that's my function for square root. Then we've got our B5, which is actually going to be the P prime cell here. So you can see this guy here is the B5 cell. So you're taking your P prime, which is the B5, multiplied by Q prime, which is the cell B6. So that's this 0.261098 value. And then remember, it said to divide by N. So your N is this 2275 value. And you can see I put all three of those inside the parentheses because remember the square root is on all three of these values, right? So all three of these that are being multiplied and divided. So you needed to do P prime times Q prime divided by N, and all of that should be underneath the square root. So that's why you will see my square root parentheses go around all three of those cells. And then you're basically multiplying the z-score value, the 1.880793, with the square root of those remaining three numbers. And then you hit enter, and you can see this is our margin of error. So again, I just did a copy paste when I typed this in here, but again, if you wanted to convert this to 2 decimal places, again, I'm just going to copy this here. And as I showed you, I can come over here to the top and decrease my decimals till I get to 2 decimal places. And you can see in 2 decimal places, that number would be 0.02. But again, I just left it as is and it accepted, right? So you can see this is what I had typed in here and it did wonderfully. Okay, so we've got our critical value, we've got our margin of error. Now we need to calculate our confidence interval. Now remember, we are talking in terms of population proportion over here. So obviously you're going to use the P variable, right? The random variable P. And you can see there are all these different options, but P was the right answer to go with. Okay, so how do we calculate our confidence interval? So for that, you will come back to your textbook and oh, right there. I knew it was right here, but I couldn't find it. So you can see the confidence interval is given to you right over here. So you will see that it is your P prime value, which remember is that X divided by N we just calculated. And then from that, you are adding and subtracting your margin of error, which is the EBP that we just calculated, right? So take your P prime and add and subtract EBP from it, or the margin of error, and you get your confidence interval. So you can see I've put that over here. So you can see how we did the calculation. So we'll calculate the lower bound here. So again, using cell references, you can see I took my P prime value and subtracted my margin of error from it. So you can see B5 minus B13 using the cell references. And then over here, you're doing the upper bound, right? So you're adding. So here we took the P prime value, and to that I added our margin of error, and you can see what my lower bound and upper bound came out to be. So you can see it's kind of, if we converted this to a percentage, this would be about 72.16%, and the upper bound would be about 75.62%. So, you know, somewhere between 72 to, I would say, 75.6%, right? And again, you will see I did not round my answers. I left them just, I did a copy paste from here. So, you know, you can use Control C or Command C, I guess, if you're on Apple, but I just used Control C here in the spreadsheet. And then I just did a Control V when I wanted to paste it here in the, you know, my Open Math answer box, and checked my answer and came out to be right. So now you've done your calculations. Now you have to conclude what you are seeing. So remember, originally, the percentage from 5 years ago of people using social media was 64%. So they're asking, can you conclude that the percentage of adults who use social media has changed? And yeah, it has changed because, like I said, you're kind of going from 72.1% or 2%, 72.2% to about 75.6, which is significantly different from the original value of 64%. So you can see I said yes, the proportion has changed, you know, since the value from 5 years ago was not inside the confidence interval. And then what happened? In this case, the percentage increased, maybe sometimes it could decrease, but in this example, of course, it had increased. So remember, the conclusion part, I think you guys can figure out fairly easily, but it's the calculation part, and you can see how I use a spreadsheet to kind of come up with my calculations, so I don't have to worry about doing this by hand. So give it a try and let me know if you have any questions. So good luck, and I'll talk to you guys later. Take care. Bye-bye.